Bosh, we have landed. We are in El Cajon, San Diego to visit Taylor Guitars. We've got a whole bunch of stuff that we're going to check out. We're going to see a lot of their different manufacturing processes. We're going to play some guitars. We're going to spec some guitars out and just going to have a bit of fun with it. This is James, whatever you want to call him. He's our new sales manager at Peach Guitars. All good?
All good. Let's take a look inside.
Let's do it. I'm standing here with Jim. Jim's going to give us a nice factory tour of Taylor Guitars. We're going to check out a few different areas, see the whole flow of the factory and see what's going on, and just have some fun with it. So, you doing well, Jim?
Doing great. Looking forward to this.
We've got about 8 buildings along our complex here. We're going to go through milling. Before stuff actually gets into the milling department, we actually go through some steps in drying and conditioning and seasoning the wood.
Yeah.
Because before you start building, you want to make sure that that wood is properly dried. Again, we're working with a variety of different species and they have different properties, right? So ebony is going to be different from spruce, and every species is on its own unique drying schedule. So we go through really many steps of that. Once we get the wood kind of ready to go, then it goes into milling, and then we're starting to process those components to get them ready.
They were showing us at the Tecate facility. It takes weeks, doesn't it, to get some of that stuff
It
ready.
really does.
Yeah.
You can't really fast forward that process. You have to kind of let Mother Nature do her thing in terms of moisture release. Over here we've got some guitar blanks, and you may know this already, but we do a 3-piece neck.
Yeah.
Our neck design is actually a patented design that we're really super happy with in terms of how it performs, how it allows the guitar to perform throughout its entire life. But you can see some of the different pieces here. That this long fiddle piece is going to be the shaft of the neck, and then also the peg head. That'll be cut separately, and then we've got heel blocks here.
Yeah.
So they're all cut from the original segment of wood, and then they're going to come together later. And so when we're going through milling, especially as we get to this point, this is a back that's already been laser cut. We've done some inlay work. We were making sure that we get that surface down to the correct thickness.
Very smooth.
That's really going to be important in terms of tone, right? The recipe of a guitar is making sure it's everything from the bracing to how thick is that back, how thick is the top, everything getting optimized for the design that Andy has come up with. So with these kinds of machines, we can really very precisely control the thickness of those components. So that's what we're doing here.
What have you got in your hands there?
This one, that's a experiment project. It looks like a Grand Pacific 517 model, but there's a couple of tweaks inside.
Tweaks going on.
There's always something. I mean, I guess that's one of the fun things about the life of a guitar maker is it's never exactly the same. And every time you go to make something, you're going to discover 10 other things that would also be interesting to try.
Yeah.
You know, so there's no end to what you could make and do.
No, and a lot of the time, with a lot of these things, all these changes, massive changes that you can make to things are all under the hood, as it were.
Right.
That, you know, all this time and effort that you put into making these changes, you know, a lot of people don't get a chance to see, do they? But what a massive difference it kind of makes. And obviously one of those the biggest things was the V-Class bracing.
That was a pretty big change for us, and for a lot of musicians.
I think you're underplaying that a little bit.
So what we've got right here are a couple of carousel clamps. So it looks like we've got some really nice Koa backs here, possibly for the 700 series. And what we've done is we've got a book matched set, so 2 pieces that really match well. They've got a nice symmetry to them, and we've glued them up. So as we glue them, we clamp them like glue sets, and then from there, we're going to just sand that, get that glue, those beads out.
How long would it typically take for something like that to dry?
It dries pretty quickly. I want to say that by the time they work their way back around to the first one, it's pretty much done. I think it's only about a 45-minute cycle. Wow. So it's pretty quick in this case. From here, these are going to come out, we'll do a little bit more surfacing, and then they're going to go over to the laser. We'll show you how we cut the actual form of the guitar top and back. On this side of the room, there are a couple things I would point out. You can see some different batches of wood here. One of the things that we do is we're sorting wood. So we want to make sure we grade it and sort it accordingly so that it's basically appropriated for whatever series is right. So we're doing that. And then we're matching sets. We want to make sure that the piece we select for the back of a guitar is going to be matched to the sides, etc. So that's that. Over here, we've got 3 laser machines. Now we use lasers This goes back to around 1995, I want to say, when we were developing the Baby Taylor, our 3/4 size travel guitar. With most of our guitars, we inlay a decorative rosette around the sound hole.
Yeah.
With the Baby, we were looking at some other production techniques to make it a little bit more affordable a guitar for folks. And so we started using lasers to etch a decorative pattern around the sound hole. That kind of opened the door to some other applications.
Yeah.
And now we use lasers a lot. We'll use them for cutting the actual shape of the top, the back, the sides.
Oh, wow.
And then we can do other more intricate types of cutting work for inlays. These are a couple of custom or limited models that we've done over the years. So this is a Pelican inlay in which some of those pieces are laser cut. So what we'll do is we'll use a computer mill to do the routing work, to pocket, to hold those pieces, and then we have someone who'll design that piece, and then they'll write a laser program for it, and then it can cut it. So we've got that.
That's incredible work.
And then we have, this is always a fun one to show folks, the running horses.
Yeah.
So same concept, but that's a couple different types of wood in there. I think it might be maple and koa, so you've got the lighter texture and the darker.
Yeah, that looks great.
So the lasers are great because we write the programs, so they're super accurate. You don't have a tool bit that's going to dull. You're not going to chip the wood. It's safer than using other types of saws. And again, you build efficiencies into the process.
So the laser would be used for like a K24 CE, like the inlay and stuff on that with it on the fretboard.
Yeah,
for doing that.
it would. In fact,
I saw that
so
one.
here's one. That's another, and this is kind of a cool, because it's a little bit more of a fluid design there. So what we'll do is we'll actually do the inlay work first, and then we'll cut the fret slots basically through it.
I want the dynamic range of a great instrument. I mean, that's what makes it so, it feels responsive. If I hit it hard, man, I want like some muscle behind it. If I play it delicately, I want a broad but responding voice. But at the same time, I want the kind of note response that you might see on like a good piano. Piano is a difficult instrument, and it's kind of easy in that you have a set of strings for one pitch. So there's a lot that you can do to manipulate that, and you press a key, you get that note. That's what you get. And so you don't have to have multiple pitches coming off of one string. You don't do that. No. And so you can regulate a piano pretty accurately. But I want that kind of feel on a guitar where if I play a minor 9, and then that major 7 over a minor, ooh, that's a spicy chord, but in a good way.
Yeah. When you add that next chord in, that's better.
It's like, I want to be able to do that.
Yeah.
So we wanted to bring you into the rosette room next. We wanted to talk about some of the processes involved in doing many different rosettes. How many rosettes, this is Garrett, by the way.
Hi guys.
How many different rosettes do we do?
Currently we have just one standard rosette for each model line. So from 100 series all the way to PS, about 10.
Okay.
We also have customs, those come through, and this is one of the only rooms in the factory where we still do the process by hand. So you just saw the lasers and the machinery that supports parts like this come into the room, and each one of these is just installed by hand, cut by hand, and they're all custom fitted. You can see the rosette parts here on the wall. They're all till length, but they all get installed by each one of these people here.
It's actually a great point because we saw the lasers. We're going to see computer mills. We're going to see robotics, and so there's a lot of high-tech stuff that happens here at the factory. But it's a marriage of that kind of technology and craftsmanship. People are still very much involved in the process, and like you say, rosette work is really a prime example of that detail work that's done.
And they'll take their time. They'll make sure each one of these joints is flawless before it moves on.
Here's something interesting. You can confirm this, but I think Andy Powers told me people sometimes ask, is the rosette purely decorative? And Andy always makes a point of saying, no, it actually has a practical function. And that is to help prevent the top from cracking along the end grain. The end grain being, I think, where the neck and the bridge in that area, because from what Andy was saying, the top in those areas along the end grain, that the top will either gain or lose moisture at a faster rate than the edge grain. So that really kind of helps prevent cracking, right?
Yeah, so after we remove the material from the top there, the balance sound holes on a few of these models here actually help support the top. So one of the old school techniques is to soak the wood. Depending on the wood, it could be a few minutes to maybe 30 minutes or so. And then she's hand bending this around a pipe bender that's about 400 degrees. So it takes a skilled craftsman to know exactly how much pressure and how long to keep that material on the bender. And I'll remember this you have to do for every single guitar that comes through. It takes that appointment at least. So our Jason Mraz signature model, all these little parts in here are laser machines cut out, and then we install them just like a little puzzle. It might look pretty challenging, but they're fairly easy.
Like as a musician, I've always played in a variety of styles.
Yeah.
And I love different instruments. I love that they are different.
Yeah.
And I love that every musician is different. We don't hear things the same way. We don't play things the same way. We don't want the same result out of every instrument. And so when I look at our guitars, I think I want to be deliberately building a wider variety of sounds because there's a place for it to go. It's not just another, like just a line item on somebody's like sales price list
just
kind
not
of
another
thing.
SKU.
It's like,
Yeah, it's
like
just-
no,
yeah,
man,
no.
I don't do SKUs. We build guitars.
Yeah.
You know, there's a place for these things to exist.
Yeah.
And it's good that not everyone is for every player.
Yeah.
Like we started building a guitar that's this Grand Pacific shape in the American Dream series called the Flame Top. It's using a flame maple top.
Which is
Weird.
weird, yeah.
It's like super weird.
But looks so cool.
It looks cool.
Looks cool and sounds great.
The sound that comes out of it
Yeah.
isn't going to be for everyone,
No.
but the flavor is so radically different.
It is, yeah. That is an awesome
You hear it
guitar.
and go, well, dang, that was a sound that I didn't know I wanted until I heard it. Now it's really cool.
Yeah, it is a
You know?
very, very cool guitar.
And if you're into that, you're probably not going to like this one over here because this is so radically different unless you're, into that taste testing kind of thing with your music.
So we got...
And so I like building in that diversity.
Are making if you're doing this manually, and for many years we did do it manually. So, you can see it being finished up in another area on one of our T5Cs, but it's if you do this all day long, strain on your lower back.
You're going to start different in the morning to the afternoon
Exactly,
as well.
and from one person to another person, it's really hard to regulate that pressure to get a nice consistent shine on a gloss finish. So we've actually been using robotic buffing units going back to I think 2001, so over 20 years now. It's obviously the systems have evolved a little bit over time, but we love the consistency that Buffy, as we call her, can bring to the equation. Anytime we can use machines and tools to take the physical strain off of people and allow them to focus on other aspects of craftsmanship, that's always amazing. This is an area where it might be good to talk about that patented neck design that we saw earlier, because I think to appreciate the Taylor neck, you kind of need to see the body of the guitar also to see how the two of them relate to each other. And so I'm going to use this as an example. I'm going to pull this out. Looks like it's a Builder's Edition 324 CE. So I mentioned we do a three-piece guitar neck. So we've got the peg head, we've got the neck itself, and then the heel. All those components cut from the same original segment of wood, but then cut into separate pieces and then glued together. A couple of benefits. One up here where the headstock meets the neck. If this were a single piece, a lot of times this is a vulnerable place, right? Your guitar gets knocked over, something, it's likely to crack, or the stress at that angle can often cause some cracking, breaking, whatever. So we strengthen the guitar neck at that end. This is where the magic happens, I think, down here, because typically you hit, if this is a 14 fret neck, which it is, you get to that 14th fret, and typically the neck itself ends at the heel, right? So you just have the fretboard kind of floating. Yeah. And Taylor we've been doing a bolt-on style neck for a long time. Yeah. And in the past, we would have this this fretboard extension basically glued onto the top. Well, we really wanted to be able to bring more stability. We also wanted to be able to set that neck angle really accurately to get that geometry just right for playability. So part of this patented design is to continue that neck almost to the very end of that fretboard, right? So it's almost fully supported. So we've got that component. And then I'm gonna, as a reference point, I'm gonna pull out the body here. And this is actually how that's going to fit into place.
Yeah.
So we've got two areas where that guitar body is pocketed. So we use a computer mill to pocket that body. And then we've got these two areas where we actually have laser cut spacers in tapered increments of like 2/1000 of an inch. So when it comes time to set the neck up, basically we can set that paddle part that extends underneath the fretboard extension into this pocket right here. Everything's going to fit in place. We will basically use a neck angle gauge that will basically tell us which pairing of spacers to drop in. So every single neck is set to an accuracy of about 2/1000 of an inch. The other cool thing is that it's wood to wood. There's no glue involved, right? So when we think about setting up the neck, not only is it going to be dialed in to play really well right from the get-go,
resonance and sustain and everything as well.
You get that, but then this is also designed to have a really long, healthy life. So at some point over time, that guitar settles into its environment. It changes a little bit. That that neck may need a reset. Well, guess what? With a tailor, you can basically a technician can go through the sound hole, basically unbolt that neck in a minute.
One last sort of question for you as well. So when you come in every day, and you've got all these cool things and all these different projects that you're working on all the time, how do you kind of decide that's like, this is what I want to work on right now? Because you must have so much going on in your head at all times of things like, I need to fix this, I need to do this, I need to see this project through. And how do you kind of think, right, now I've got to stick with this one and work on it?
I'd like to say I do it well. I don't think I always do it so well. Because you're right, there are projects that are for 10 years from now, projects that are 5 years out, projects that are for next year or 6 months from now, or things that you're working on for next week. And they all got to keep moving. But they move at slightly different paces. So yeah, you spend a lot of time working on the day-to-day things. That's true. And then I deliberately schedule and devote some time to go, well, this is something that I think should someday exist.
Sooner rather than later kind of thing.
Or later rather than sooner sometimes. Go, I think it should exist. I'm interested in it. I just want to see where it goes. And sometimes it's an idea where you go, oh man, I wish I hadn't built that guitar because now I really want it to exist.
It's caused me more problems now.
I can't manufacture that guitar. Because that is a possibility that you could build something that you go, I can't regularly do that. At least not yet. Not until I invent X, Y, and Z to be able to make it. So there are a lot of things like that exist. I mean, the V-Class idea was actually in the works for a number of years before it ever got launched. Partly because the tolerances that you need in order to make it work, we weren't quite capable of at the time.
Actually, we can show you this. So here we can see the frets being pressed in place. So this is actually an arbor press. So we've got the computer mill that will slot in preparation, and it'll because it's a computer mill, it's accurate, so the depth is precise. And at this point, we're still pressing those frets in by hand, and there's something about doing it manually for us where we can feel when those frets are seated properly. And you also want to make sure that you don't over-compress them because you can kind of flex the alloy. So there's a certain feel to it. We use carousel clamping systems a lot because you can work, again, very efficiently. Everything just rotates around a wheel. And again, this kind of stuff's also built in-house, so the tooling guys come to the rescue once again. We've got a wheel press here, so we actually have a body in there. So upstairs, the top and the back have gone through the bracing process. And then the sides are also bent. We've got automated side benders up there that take care of that part of the process, and then it all comes together here. So our craftspeople are going to apply glue along those edges, set it up in a clamp, and basically just give that a nice tension just to secure it, and it's a pretty short drying time.
Guys, we had a rundown earlier showing us how they do that armrest. It's amazing.
It is
so much handwork.
It really is a lot of handwork. And we've got this. Here's a nylon.
Right. Oh, cool. Here
So
we
you
go,
can
yeah.
see that more
Yeah,
fan
brace,
style
yeah.
bracing pattern. Notice like with nylon, less string tension, so the bracing pieces are obviously a different pattern, but also super thin.
Thanks for watching, guys. Really appreciate it. Keep checking out the channel. There'll be more stuff happening here at Taylor. So I want to say thanks
Hey.
to Andy for your time.
Thanks for
and
coming, you guys.
Yeah, thank you very much. Cheers. Bye-bye.